So continuing on with rational functions. We saw right now the ones that we've done have taken this shape. They look something like this, and there have been lines, dashed lines we had to draw as part of our graph because the curves don't touch them. What did we call those lines that a curve? Asymptote. And there's vertical and there's horizontal. So we saw ones that look like this. The last one we did was actually in this section. Follow the same procedure. Now it looks a little bit different. Instead of 1 over x, it's 1 over x squared. Okay? How is that going to look compared to 1 over x? Well, best way to do it is a table of values. See what it looks like. So if x is -2, what is 1 over -2 all squared? 1/4. If x is -1, what is 1 over -1 all squared? 1. If x is -1/2, what is 1 over -1/2 all squared? -1/2 squared is 1/4, is 1 over 4. And 1 divide 1/4 is the same as 1 times 4 over 1, which is just 4. If x is 0, undefined, we can't divide by 0. Can anybody tell me what that means in terms of when we graph it? There's going to be a gap, and what do we draw in that gap? What do we call that line? An asymptote, right? Okay. Yeah. Okay, if x is 1/2, then we get 1 over 1/2 squared, which also works out to 4. 1 over 1 squared is 1. 1 over 2 squared is 1 over 4. So if we sketch these, -2 is 1/4. -1 is 1. -1/2 is 4. +1/2 is 4. 1 is 1, and 2 is 1/4. And remember, there's no value at 0. So x cannot be 0, which means we need to replace it with a vertical asymptote. In addition, as x gets bigger and bigger, this fraction gets smaller and smaller, doesn't it? Like we got 1 over 4, and then if we had 1 over 16, that's smaller. If we had 1 over 256, that's smaller, right? The bigger the denominator in a fraction, the smaller it is. So it keeps getting smaller and smaller and smaller. Does it ever hit 0? No, it just keeps getting to be a really small fraction. So that means we have a horizontal asymptote as well. We can never get y to equal 0. There's nothing you can plug in for x so that 1 divided x squared is 0. It's nothing. So there we have a horizontal asymptote that our curve goes along but never touches. And we have a vertical asymptote. Pretty similar to the previous one, except it kind of makes sense that this section would be flipped up, because when we square something, if it's already negative, doesn't it make it positive? So in a way, we kind of flip that up. So that's what x squared looks like. Still has a couple of curves in it, still has gaps in it, let's answer these questions. And remember, for the intercepts, if we can answer them from the graph, that's the ideal. But if we can't answer them from the graph, or it doesn't look, if it looks too hard to estimate, then we have to use algebra, right? What's the vertical asymptote? Sorry? X equals 0. Remember, vertical asymptote always begins with X. A vertical line always begins with X. Horizontal, Y equals 0. The intercepts we can pull off the graph. Where does it cross the y-axis? Or sorry, the x-axis? It doesn't. So there is none. Where does it cross the y-axis? It doesn't. So that is none as well. Okay? I left space for work here, but we don't need to in this case. Now remember what we talked about domain and range? That if you use interval notation, it's a little complicated. So we use the not equal sign. Because for the domain, it's everything, right? Except 0. How do I write that? X not equal 0. Which means that's it. It's every number except for 0. And that's the same for y. The range, oh, sorry, that's not the range. Oh, my mistake. Ah, what is the range?
Not including 0 and everything above.
Not including 0 and everything above to infinity, yes. That we can use interval notation. So, you see how we can get our asymptotes, we can get some points, and then see how the shape develops. That's basically how you graph these rational functions. So let's look at a couple more. This one. Here we have 1 over x squared, but it's got -4 in the bottom. Okay. What are the non-permissible values? What value of x, or values, would make the denominator work out to 0? +2 and -2. So you could do it like this. Set yourself up a quadratic equation. I am looking for x so that x squared minus 4 is equal to 0. Therefore, x squared is equal to 4. X is equal to plus or minus square root of 4, which is plus or minus 2. So that means we have 2 vertical asymptotes. There's 2 places where x is not defined. Okay? So vertical asymptotes at x equals -2 and +2. So it's going to look like this. Remember, dashed lines and always arrowheads. Because asymptotes go on forever. What would the horizontal asymptote be? What was it in the previous one? 0. It's still the same. The only time the asymptote moves, okay, is if there was, no, actually, we can't do that with this one because it's not an x function, it's x squared function. Yeah, just the horizontal asymptote remains at 0 because there's nothing you can plug in for x to make this equal. Because 1 divided what is 0? No such number exists. So the horizontal is still there. Notice we've got kind of three sections now. We've got this section, we don't know if the graph's here or here. We know it doesn't touch here. Something's going on in this section. And something's going on in this section. So we got to figure out what's going on in each section. So this is why we want to identify points around the vertical asymptotes. And to remember how we do that, so what's the what's the closest integer to the left of -2? -3. Let's see what happens at -3. And then the one to the right of -2 is -1. Let's see what happens at -1. For this one, let's see what happens at 1 and 3. So we do 1 over -3 squared minus 4, which gives us a fifth. So -3, it's positive, but it's pretty close. At -1, we've got 1 over -1 squared minus 4, which is -1/3. Well, that's interesting. So it's like this. At 1, it's going to work out to the same thing. As 1 over 1 squared minus 4 is -3. So at 1, the answer is also going to be -1/3. And at 3, it's going to be the same as -3. Because 3 squared minus 4 is 5, which gives us 1 over 5. Let's just ignore this center section because this is new to us. Okay, but what do you think is happening here? What do you think the shapes are going to look like here? What did they look like in the previous ones with x squared? Weren't they curved like that? Same thing. Same thing. I should have done a different color. But what's happening down here? Okay. So, and to get that, the behavior near the non-permissible values. We already did that. As x approaches -2 from the left and +2 from the right, phi gets larger. What do I mean by that? That means here's -2, right? If I approach -2 from the right, y is getting bigger. If I approach +2, this asymptote from the left and then from the right, if I approach +2 from the right, it's also getting bigger. But what's happening when I approach -2 from the right and +2 from the left? Well, what turns out is that it's actually getting smaller. So it goes down along those asymptotes. So what that means is as x approaches -2 from the right, and 2 from the left, y also, or sorry, y gets smaller. That's what it means by what's the behavior around non-permissible values of the asymptotes. So what's happening to the graph around those two? End behavior, I talked about before this. What's happening at the ends? Well, we said as x gets bigger, y approaches 0, right? As x gets really small, y approaches 0. So that's the end behavior. As x gets really large, and really small, really small, y approaches 0. Okay. You notice we haven't finished this yet, have we? Okay. Like what's happening in between these two? I mean, is it going like this? Is it going like this? Is it going straight across? I don't know. Okay. Well, one thing that can help us figure it out, let's find the y-intercept. Let's see where the y-intercept point is. So to find the y-intercept, remember we make x equal 0. We're going to find it using algebra. So therefore y is equal to 1 over 0 squared minus 4, which is what? What is 1 over 0 squared minus 4? Negative 1 over 4. Which means somewhere around there. Which means it goes like that. It's like an upside down parabola. So we were able to finish the graph. What's the x-intercept? That you can get off the graph. Look at your graph. Where does it cross the x-axis? It doesn't. So there's none. So there's no x-intercept. And finally, what's the domain? X doesn't equal, sorry? 0? Sorry? Negative 2 and 2. That's right. Remember, it's the domain is always x not equal to whatever the vertical asymptotes are. Okay. So notice with x squared, if x squared's on the bottom, notice it starts to take different shapes depending on what's with the x squared on the bottom. Like right now, we saw if there's nothing with x squared on the bottom, then that means it's going to look like this. If it's got something with it on the bottom, and you can factor it, because that was another way we could have found this. What's x squared minus 4? Isn't it x plus 2 times x minus 2? So if we set that equal to 0, x equals negative 2 and positive 2. So I could have solved it by factoring. If the bottom can be factored, there's going to be 2 asymptotes. And it's going to look like this. What if, and this is the final one, you can't factor the bottom? What are the non-permissible values? What value of x would make the denominator work out to 0? Can you factor it? X squared plus 2? No. Okay? Like, doesn't this have to be, in order for this whole thing to become 0, doesn't x squared have to be negative 2? Right? So that when I add 2, I get 0? Well, what squared gives you a negative? Nothing. So there is no vertical asymptote in this case. No NPV. No vertical asymptote. So that means it's not going to skip over. There's not a gap anywhere. However, there still is a horizontal one, and it's still at y equals 0. So it's still here, because if you think about it, what value of x could you plug in so that the whole thing works out to 0? Nothing. Because 1 divided by, there's no such number that you can divide 1 by to get an answer of 0. So that means y can never be 0, so there's a horizontal asymptote. Well, what's the points around the vertical asymptote? There's none. So we don't have to worry about this step, because there are no vertical asymptotes. Or sorry. Yeah, that's right, none. Identify points. And the behavior is also none. It's just not applicable. Because there's no vertical asymptotes to see what's going on. But what's the end behavior? Think about it. As this keeps getting bigger and bigger and bigger, what happens to this? It keeps getting smaller and smaller and smaller. Like if you think 2 squared plus 2 is 6, right? So you get 1/6. So if x is 2, it's 1/6. Let's do 20. 20 squared is 400 plus 2 is 402. 1 over 402 is really small. Okay, so it keeps getting smaller, but it will never hit. Will it ever get to 0? No. So therefore, we know the ends are going to look something like this. I just don't know what's happening around here. Like can't go like this, because there's no gap, is there? So it can't do this. Somehow it's got to connect. Somehow these have to connect. But the question is, where do they connect? Like, does it go up and then come down? Does it go flat? I'm not sure. This is why, what can we find? The y-intercept. So before I get to the y-intercept, the end behaviors once again as x gets really large and really small,
Y approaches 0.
let's find the y-intercept by making x equal 0. So therefore, our equation is going to look like y, and what says f of x, but f of x and y are the same thing. 1 over 0 squared plus 4, which gives me what? 1 over 4, right? So it's 0 squared. Oh, so it's a half. So it's actually down here. So what's it going to look like? I have to erase part of this. It's almost going to look flat. There's going to be a little bit of a bump at a half. A little bit. But then it starts getting closer, and I should, I'm going to be a little bit more precise with that. It's hard to on the smart. So it's a half, and then it goes down and gets really close. That's a little better. That's a little better. Couple more things. What's the x-intercept? None. No x-intercept. What's the domain? Remember, there's no vertical asymptote. Isn't it everything? It's everything, isn't it? Because there's no vertical asymptote, it skips over. So sort of how I remember these things, just to finish up, these last three that we did. I always think to myself, if there's just an x squared on the bottom, and then some number up top, I always think of it that it looks like a volcano. Okay? If there's something on the bottom of the x squared, and it can be factored, I think of it as the erupting volcano, meaning there's some lava coming up. If the bottom can't be factored and there's no horizontal, like this, I think it's not a volcano, I think of it as a speed bump. Or a what? Okay, do what? Or a little hill? I don't know. To me, it always looked like a speed bump. Anyway, those are, I just sort of gave them names because with the x squared on the bottom, you can see there's different shapes. I mean, they all involve some type of curve, and they all involve some type of asymptote, horizontal, vertical, or both. Okay? Or they're all horizontal. 2 of the 3 have vertical. Okay, so that takes care of that.